The hemiacetal below is treated with O18 labeled methanol and acid. Where will the label appear in the products? So for one thing, this here is the hemiacetal, and we can recognize it because there's a carbon here that's bound to a hydroxyl group and then an oxygen that's part of like an OR group, where the R is just a hydrocarbon chain, right? This is the hydrocarbon chain actually. Okay, so this is a hemiacetal, and it's reacting with the methanol, and then you get this product. And notice that actually the CH3 oxygen component of the methanol, right, is now attached in place of the hydroxyl group on the cyclic ring, okay, or the ring. And so they're asking us, if the labeled oxygen started in the methanol, which oxygen would it be in the products, okay? And would it be in the water? Would it be right here? Or would it be at A, okay? So here we have to think about mechanistically what might be happening, right? Well, this is looking like a nucleophilic substitution reaction catalyzed by acid. And so one could predict, right, is that the acid, let's say it's like sulfuric acid, which is a strong acid, it's producing like a bunch of protons in solution. These protons can actually be taken by this oxygen, okay? And ultimately what that will do is it will actually produce this activated leaving group, okay? Or sorry, the positive charge would not be there, it would be on the oxygen, okay? So this is a good leaving group, all right? And then what that allows for is that this nucleophile, which is the methanol, because it also has a lone pair of electrons on the oxygen, right? It's a weak nucleophile, but because this carbon is now particularly electrophilic, since now this leaving group, the OH, is protonated and has a positive charge that's drawing a lot of electrons toward it, this can now attack and act as a nucleophile, all right? And then ultimately, this leaving group will leave, this will get deprotonated, and you'll get this, right? And so since this was the original O18, right, we can see that that's actually what becomes attached to that carbon. And so the only thing that will have the label will be B, right? This is where it started, and that, of course, is what actually becomes bound to the electrophilic carbon. So that's where the isotope will be, right? So it will only be in position B.